Hi guys, welcome to my channel. This video is dedicated to solving practice problem 2 in the Unit 6 Lesson 4 packet, so let's get started. Just looking at this problem, I can see that there is a lot more information than in previous problems, so I am going to annotate as I go. Saccharin, a sugar substitute, is a weak acid with pKa equals 2.32 at 25 degrees Celsius. Okay, so saccharin, sugar substitute, a weak acid, and it's got a pK of 2.32. It ionizes in solution as shown above, so I'm going to say that this is actually my saccharin. Calculate the pH of a 0.1 molar solution of this substance. Hint, pH is the negative log of H plus. How might you calculate Ka from pKa? Okay, well, I'm going to use the Rice's table again. So let's get that set up. Cool thing about this problem is they've already given me my equation, so I just have to bring it down here. Cool. My initial concentration of saccharin is going to be 0.1. We're going to assume that the initial concentration of H plus and the conjugate base are 0. Again, there are no products present initially, so the reaction can only shift right. So this is going to change by minus x, while these change by plus x. Cool. Now, I typically relate these terms using the acid dissociation constant or the base dissociation constant, but I don't have that. Instead, I have this thing called pKa, which is something we've never seen before. But let's, think it through. So pH is equal to the negative log of H plus. In chemistry, this P basically just means the negative log of. So it stands to reason that pKa is equal to the negative log of Ka. And that's actually true. That's what pKa is. So now I can rearrange this to solve for Ka as 10 to the negative pKa is equal to my Ka. So in this case, it is 10 to the negative 2.32 is equal to Ka. And I get that my Ka is equal to 4.79 times 10 to the minus 3. Cool. So now that I know what my Ka is, I can continue to solve this problem like I usually would. So Ka I'm going to start by writing the general expression is equal to my concentration of H plus over my concentration of N C7, what is it, H4 SO3 minus all over the concentration of H and C7 H4 SO3. Cool. Ka is equal to 4.79 times 10 to the negative 3. My H is X. My conjugate base is also X. Again, I'm working with a weak acid. I have a relatively small acid dissociation constant, so I'm going to assume that the effect of dissociation on the concentration of my saccharin is negligible. So in my denominator, I'm just going to have 0.1. X is ultimately equal to 0.0219. So I'm going to plug that into my solutions row in my Rice's table. And now I've solved for my concentration of H+, which means I can solve for my pH. As we said earlier, pH is equal to the negative log of the concentration of H+. In this case, pH is equal to the negative log of 0.0219. And we get that our pH is equal to 1.66. That's all for this problem. See you guys for the next one.